Let's look at number 7 here. It's an interesting one, the way it works out. We're going to find the area of the region enclosed by the graphs of these two functions. Seems like we've been doing a lot of these problems in this section. Again, I want to find the points of intersection in this case. So I'm going to equate the outputs of these two functions together. So g of x equals f of x. G of x is here, f of x is here. And I'm going to set this equal to 0. So I'm going to add 13x squared, which makes this 26x squared, subtract 13x, right, and subtract the 260. Now, interesting thing here is, we want, say, I'm going to use the quadratic formula. Well, you got some big numbers here. Notice that 26 actually is a factor of all of these coefficients here. All right. 26 goes into 78 3 times and into 260, of course, 10 times. So I'm going to factor that out first, leaving x squared minus 3x minus 10. And then that easily factors, right, is x minus 5 times x plus 2. And so no quadratic formula needed. So factoring, if you can do it, is much better. So notice that x is either -2 or 5, and those are the x coordinates. And I got a rough draft. We've got two parabolas, right? The f of x parabola is because the negative coefficient of x squared is a parabola opening downward. G of x is a parabola opening upward. You can, plot points enough to see these graphs clearly. Again, this is just a rough graph of what they look like. So here's f of x opening downward, g of x opening upward, and they have these points of intersection at x equal -2 and at 5, where both functions actually are equal to 0 at that point, I believe. Okay, so do you see the region I've shaded in that we need to find the area of? That region is vertically simple. And the top function is f of x, and the bottom function is g of x. So to find the area, I'm going to integrate from -2 to 5. Top function, which is f of x, remember f of x was this output right here, minus the bottom function g of x. And there it is. I mean, now it's just a little bit of algebra to simplify. I would indeed simplify, distribute this negative through, combine like terms, and basically look at this. This is essentially the same thing I had up here. It's just negative. It's just -1 times what I have here. Go ahead and simplify this by what? Factoring out. I'm going to factor out -26, leaving positive x squared minus 3x minus 10. And that just makes finding the antiderivative easy, right? What's the antiderivative of x squared? 1/3 x cubed. 3x is 3/2 x squared, and 10 is 10x. Of course, subtracting those. And I still have this -26 out here. Now I'll just plug in 5 in for x here, -2 in for x here, and then I can subtract these two and then multiply by -26. You can use your calculator to help if you need to with this to convert this to a fraction and this as well. And when I subtract those, we get to this final fraction here times -26. Good thing we got -26 because a negative times negative is a positive. And you should be getting positive values for the area of these regions, right? If you get a negative value, something is wrong. Could be that you subtracted in the wrong order, that you did the bottom minus the top instead of the top minus the bottom. Okay, so again, your numbers might be slightly different than this one, but it should work out very similar to this. Okay, hope this helps.